Low power consumption equipment, like wireless sensors, transmit information using bursts in order to save battery life. In this mode, the current draw of the circuit in standby mode is quite different than when it is transmitting. This can lead to a complex waveform that can be quite a challenge to measure. Fortunately, we have some tools that can make it easier. Let's take a closer look at measuring this kind of signal with the level trigger function of the Regal DM3068 digital multimeter. For this experiment, we are going to use a Regal DG4000 arbitrary waveform generator to source a 3-step pulse waveform to approximately simulate the current waveforms in the 3 work states of a low power consumption device. For reference, these states are standby, receive, and transmit. As can be seen, the time of the receive and transmit states are only a small part of the total cycle. Next, let's measure the signal in each state. In order to observe the signal more clearly, we connect 2 identical signals to the oscilloscope and multimeter. Now, through the waveform displayed on the oscilloscope, we can see that the duration time of the receive state is 30 milliseconds, with an amplitude of 1.79 volts. The duration time of the transmit state is 20 milliseconds, with an amplitude of 1.97 volts. An oscilloscope can be helpful in measuring these types of signals, but the measurement accuracy of a multimeter is much greater. Let's have a look at how to measure the above signals using a multimeter. To measure the voltage of the receive state, let's configure the trigger level function to trigger the multimeter when it begins to receive, and then set the integration time to 30 milliseconds. Here are the steps to configure the trigger level. Select DC volts measurement, 2-volt range, and disable the auto zero function. Change the trigger type to level trigger, and set the level to 500 millivolts. Now enable the trigger function, and then configure the trigger parameters. Sample number to 1, delay and rise slope to 0. Then configure the measurement integration time to 30 milliseconds. After finishing the configuration, the multimeter displays the signal in the receive state. According to the requirement, we can also perform basic math operations for more complex measurements. Now let's measure the voltage of the transmit state. Recall that the transmit state begins 30 milliseconds after the trigger point, and the integration time should be set to 20 milliseconds. Let's set the trigger delay time to 30 milliseconds. And then set the integration time to 20 milliseconds. After finishing the configuration, you can see that the multimeter displays the transmit signal. The last measurement is the voltage in standby mode. To capture the signal, the multimeter should be configured to trigger on the falling slope with 0 trigger delay, and a measurement time of 900 milliseconds. First, set the trigger delay to 0. Then select the fall trigger slope, and set the integration time to 900 milliseconds. After finishing the configuration, we can see that the multimeter displays the standby time signal. This concludes our introduction to the level trigger function of Regal multimeters. The key points are: read out the time parameters through an oscilloscope, set the basic measurement parameters of the multimeter, disable auto zero function, Select the trigger level and set the trigger parameters to match the time duration of the signal of interest, and then set the integration time.